Hello, science teachers. Welcome to From Classroom to Campus. I'm Deja Crossman, and today we're talking about making the leap from teaching biology or any science in K through 12 to teaching adults in higher education. Now, before you panic, no, you won't need to memorize another 200 bones in the human body or redo Punnett squares on the fly. What you'll need is a shift in teaching style, moving from pedagogy to anagogy, which is teaching adults. In this episode, we'll explore that shift, share some science-centered best practices, highlight a success story, and I'll be honest about some of my own hesitations. Let's jump in. In K through 12 science, pedagogy rules. You'll set the pace, design the labs, and guide students every step of the way. But with adults, it's different. Malcolm Knowles described anagogy as the art of science of helping adults learn. Adults want to know why they're learning something. They bring their own experiences and careers into the classroom. A 10th grader might ask, "Will this be on the test?" An adult nursing student might ask, "How does this process affect my client's treatment plan?" As biology and science teachers, we're used to controlling the experiment. In higher education, our role shifts. We're facilitators, mentors, and co-investigators. Instead of giving students the answers, we help them connect science to the real world they've already lived and worked in. So, how do we make that shift successfully? Here are 3 best practices. First, we make it relevant. Adults thrive when science connects to their daily life or careers. If you're teaching cell biology, link it to nutrition, medicine, or even athletic performance. If you're teaching ecology, connect it to climate change or sustainable agriculture. Second, use their experiences as data. In K through 12, you might be the primary source of examples. This differs in higher education because adults bring real-world knowledge. A discussion on genetics can be enriched by a student sharing about agriculture, while another student can share about healthcare experiences. Third, give choice and flexibilities. Adults juggle jobs, families, and life. Offering multiple assignment formats respects their autonomy and keeps them engaged. And research shows this matters. Studies consistently find that when adults are treated as partners in learning through collaboration, real-world application, and autonomy, retention and motivation goes up. And let's be honest, it makes our jobs more interesting as well. Here's a science-specific example. A biology professor redesigns her microbiology course for adult learners. Instead of endless lectures on bacteria, she has students work in teams to investigate real-world case studies, like foodborne illnesses outbreaks. They analyzed data, traced sources, and presented solutions as if they were a part of a public health team. Students didn't just memorize cell wall structures, they learned to apply microbiology to real problems. Engagement increased, and several students said it was the first time they really saw themselves as scientists. That's anagogy in action. Problem-centered, collaborative, and authentic. Now, let me share some of my honest concerns. In K through 12, I'm used to scaffolding lessons, keeping the class tightly structured. Whereas in a higher education section, you will need to let go some of the control and let students drive their own experiments, projects, and discussions. One question I have for myself is, will I provide enough freedom, or would I be able to challenge them without overwhelming them? These are real questions that I wrestle with. But They also remind me that teaching adults is about being flexible, reflective, and also being willing to grow alongside my students. So, science teachers, if you're thinking about making the jump into higher education, remember this. Adults don't just want the what of biology, they want the why and how it applies. You already have the foundation, you just need to adjust the delivery. Thanks for tuning in to From Classroom to Campus. Until next time, keep experimenting, keep inspiring, and remember, whether it's kids or adults, curiosity is the spark that makes science come alive.